For these two examples, give it a try on your own first before you continue the video. In part 8, we have a third degree function, and the first thing we want to do over here is to factor out the GCF. And for the three coefficients we get, the GCF we get will be 3 from the constant part, and for the variable part, we can see all three terms contain the variable x, and the lowest degree we have is x to the first degree. And that's what we're going to factor out as part of the GCF. Once we do so, we will see the first term we have left will be x squared, minus the second term will be 2x, and then for the last term, we get just minus 3 as a result. And once we do so, we can set this to be 0 and use a zero product principle. So using the zero principle, we can have 3x equal to 0. So further is the second option where we have the quadratic equation essentially to solve using quadratic formula. And x is equal to negative b plus minus square root of b squared minus 4ac all over 2a. And plugging everything in, negative b will be negative of negative 2 plus minus square root of negative 2 squared minus 4 times 1 times negative 3. And this is all over 2a, so 2 times 1. And to simplify this, we would have negative and negative 2 being positive 2 plus minus square root. Under the radical, I have negative 2 squared is 4, and then also the negative 4 times 1 times negative 3 gives me 12. So 4 plus 12, which would be square root of 16. And this is all over 2. And to simplify this, square root of 16 becomes 4, and I really have 2 plus minus 4 all over 2. And therefore, we can say x is equal to, there are two options. If I add 4, I would have 2 plus 4 is 6. 6 divided by 2 will be 3. Or if I subtracted 4, 2 minus 4 is negative 2. Divided by 2 will be negative 1. And therefore, I have two x values that would work. And to put it all together, the horizontal intercepts I have is 3, 0, negative 1, 0. And don't forget the first one we found, which was 0, 0 over here. And therefore, these are the three intercepts we have. And this is a third degree function, so we can get up to 3 different horizontal intercepts. And now for part B, we have a higher degree function. We want to go through the same process over here. And if this wasn't obvious to you what the GCF is, definitely do some factorization on the side, and you will find out the GCF between the three is going to be 7. And for the variable part, the lowest degree of the variable we have in common is t cubed. Once we do so, 7 times 9 is 63, so I'm left with 9t squared minus 7 times 5 is 35, so 5t, and then plus 5 over here. So once we do this, we get this is equal to 0, and therefore either t cubed is equal to 0 or 9t squared minus 5t plus 5 is equal to 0. And for the same argument as the zero product principle, you can really break down t cubed to be t times t times t, and that leaves us the only option possible is t is equal to 0. Alternatively, you can just think one number times itself is going to be 0. The only way to get 0 is to just have 0 as a factor. And alternatively, we have this quadratic formula we can use. I'm going to write it down again first. And negative b will be negative of negative 5 plus minus square root of b squared, which is negative 5 squared, minus 4 times 9 times 5. And by now I hope you are getting used to the quadratic formula and also paying attention to the radical part of the quadratic formula. Here, if we look at the quadratic formula part, or the radical part for the quadratic formula, we would get, under the radical, we have square root of 25 minus some big number, right? We'll actually calculate it. 45 times 4 is 180. This whole process, and this whole factor or multiplication gives us 180. Here, if we see this result, or this difference gives us a negative result over here, we would know that we can't find any real number solution over here. So we can say there is no real number solution, or no real solution for the equation over here for the quadratic part. And therefore we won't really find any t that would make this expression equal to 0. So this is not going to produce any additional horizontal intercept. Therefore, the only thing I'm left with is going to be t equals 0 over here. And then we would get the only horizontal intercept is equal to 0, 0 over here.